Hello. Let's continue our class. And next, I will introduce pointer subtraction. Now, suppose P points to the element at the index 1, and Q points to the element at index 5. And suppose we perform pointer subtraction. We perform P minus Q. Then this will return an integer. So if you perform pointer subtraction, this will return. This expression will generate an integer, and this integer is the difference between the two indexes. So this integer is 1 minus 5. So here P minus Q is -4. And if we perform Q minus P, this is pointer subtraction, and this will generates an integer. So this corresponds to 5 minus 1, so which is 4. If you print the memory address of P and Q, you will find the difference between the two memory address is 16, because this is hexadecimal. So this is the difference is 16. And if you perform Q minus P, the value is 4. So Q minus P means 5 minus 1. So Q minus P is 4. The difference between the two indexes. However, the difference between the two memory addresses is actually 16. This is because each element is an integer, and one integer takes 4 bytes, and 4 times 4 is 16. Now we can go to the page 4. Page 4, I use a figure to illustrate pointer subtraction. Now suppose we declare an array with 5 elements, and its initial value is 1, 2, 3, 4, 5. This is the memory contents, and the corresponding memory address is shown on the left hand side. So the memory address of the first element is 4000, and the memory address of the next element is 4004. And next we declare a pointer P. And P is point to the element at the index 0. So we know that the memory contents of P will be this number, 4000. Because P is a pointer, its value is a memory address. So the memory contents of the pointer is a memory address, and now P points to the element at the index 0. So the memory address at the index 0 is 4000. And also P has its own memory address, but usually we don't care about the memory address of a pointer. We only care about the value saved in this variable. And the Q is another pointer, points to the element at index 2. So the element at the index 2 has memory address 4008. So the memory content of the pointer Q is 4008. And also pointer Q has its own memory address. And now suppose we perform Q minus P. Now here we perform pointer subtraction. So this means we perform 2 minus 0. So the value of this expression is 2. So this operation does not mean we directly subtract the 2 memory address. This operation means we compute the difference between the 2 index. So we perform 2 minus 0. You can use this figure to help you understand the mechanism and the usage of pointers. Next, I will show how to use pointers to process arrays. And first, we recall that if we want to access elements in an array, we can use the brackets with index. This is the method 1. We can use brackets and index to access array elements. And we can also use pointer. You can let pointer points to the first element, and you perform pointer addition and use the reference operator to retrieve the value of array elements. This is the second method. We also has the third method. The third method is also use pointers. We let Q points to the first element, and then we perform pointer addition. We perform pointer addition. This means the pointer points to the next element, and we can use star Q to get the value of the array element. So for this one, you don't need to use parentheses. You don't need to use parentheses because you perform the Q is already moved to the next element. So here we don't need to use the parentheses. So this looks more convenient than the second method. So method 3 looks more convenient than method 2. And we continue this iteration until q is less than uh, uh, q is less than ARR plus array size. ARR is the pointer to the first element, and we perform pointer addition. So this is also a pointer, points to the element next to the last element. So this is method 3. Later we will learn vector. So after we learn vector, I will introduce how to use this one. So all the methods can be used to access array elements. My suggestion is that the simple one is the best one. So method 1 is the best style to access array elements. Method 3 is often used in the C programming language. In the C programming language, if we want to deal with character arrays, we often use pointers. However, in the C++ programming language, we use string data type to replace the character array, the C strings. So in C++, we seldom use this style. Next, I will introduce the usage of pointer and the array. Here, suppose we declare an array. This is a static array, and we declare a pointer ptr. The data type is int star. And we can assign ARR to PTR. This means PTR is point to the first element of this array. However, we cannot assign PTR to ARR. This is because ARR is the array name, and the array name is like a constant pointer. Constant means its value cannot be changed. So we cannot change the value of a constant. So if you try to do this, this will cause syntax error. So if you try to do this, this will cause syntax error. But we can assign ARR to, we can assign the array name to a pointer. So the array name behaves like a constant pointer, but its data type is not a constant point. But its data type is not count int star. Its data type is int bracket. It's actually a separate data type. Next, I will introduce how to how to declare dynamic arrays. And first, I will mention the limitations of static arrays. If we use static array like this, if we use static array, we need to specify array size. So if we use static array, we need to specify array size. However, this might create, this might waste memory, because we often allocate more memories. For example, I allocate 1,000 elements, but the following statements might only use 100 elements, and this means I waste 900 elements. So if we use static array, we might waste memory, because we need to estimate the maximum size needed. And the dynamic array does not have such limitation, because the dynamic array can grow or shrink as needed. So this is one advantage of the dynamic array. And to create dynamic arrays, we use the new operator, followed by the data type, and followed by a bracket. And inside the bracket is the array size. So this expression allocates 10 integers, and this operator will return a pointer to the allocated memory space, and this pointer is assigned to array PTR. And then we can use this pointer to access this array like an ordinary array. So we can use index, and we can use bracket to access array elements. If we finish the processing the array, we can return the memory. We can return the located memory. And to do this, we use the delete operator. And because we allocate an array of integers, so here you need to add a bracket, a pair of brackets after delete. If you omit the brackets, you will not eliminate the entire array. You only return the first element, and you don't return the entire array. So if you allocate an array of integers, and if you want to return the allocated memory, then you need to use a pair of brackets after the delete operator. And I have finished the introduction to pointers and to dynamic arrays. And I have some suggestions. Suggestions. My suggestion is to avoid avoid to use pointers and avoid to use dynamic arrays. And because use pointers is dangerous. Because using pointers means you directly manipulating the memory address, and directly access memory address is very dangerous. Because if you put some value in the wrong address, this can cause your operating system to break down, or to cause your program to have runtime error. So using pointers is very dangerous, and many programming languages do not have pointers. For example, we can avoid the use of pointers. For example, we don't need to use pointers to achieve call by reference. You can use the ampersand operator to achieve call by reference. So you don't need to use pointers. And using dynamic arrays is also not recommended, because you need to manually allocate and manually delete memory. And this is not recommended, because if you do not properly return the memory, this will cause memory leakage. So my suggestion is to avoid to use dynamic arrays. And I will introduce another data type. I will use another data type, vectors, to replace the use of dynamic arrays. Vectors is like a dynamic array. You can grow or shrink its size, but you don't need to manually allocate a memory. So using vectors is better than dynamic arrays. And let's see the contents of this chapter. Vectors is a library. It's a data type defined in the. This is a data type defined in the standard template library. You can see the table of contents of the textbook. In chapter 19, the textbook will introduce standard template library. And inside this library has many data types. And I will introduce the vector data type. Now suppose I want to declare an array of integers, and you can use vector, the vector data type. This is a template. This is called a template class. A template means we use the angle bracket. If you see expression using angle bracket, this is known as template. And inside this angle bracket is the data type of the elements. So we want to declare. So you can think vector as a container, and this container has many elements, and each element has data type integer. So you can inside the angle bracket we specify the data type of each element. You can use double or other data types. So in order to use the vector, you need to include the vector library. And you can, this is like declare a static array. So you declare my vector. This is like an array, and this array has 3 elements. And we use a pair of braces to initialize this vector. The data type of the element is integer. And after we declare this vector, we can use the index to access this vector, the element in this vector. And the vector has one member function, size. You can use this member function to obtain the vector size. For this example, the vector size is 3. So we can use this member function to get this value. So the vector is like a static array. Oh, but if you use static array, you do not have this member function. So if you use static array, you need to manually write down the array size. The second method is to declare. The second method first declare a vector. A vector is a container, and initially its size is 0 because initially it does not contain any elements. And then we use the pushback member function to push element inside into this vector. We can try to print the size of this vector. we see that its size is 0 because initially it does not contain any element. If you give some initial values, then the size function will return does not return 0. And we can use pushback to aid elements. So first I declare a vector and I push back I push back 3 elements into this vector. So after the statements, my vector size is the size of my vector is 3, and I use the for loop to print its elements. So its elements is 5, 6, 7. And this behavior is very different from the static array. Recall that if we use static array, we cannot create an empty array. You can create an empty array, but you cannot add any elements. You cannot add elements to this array. So you have no way to add elements to a static array. But if we use vector, we can add elements to this vector. So this behavior is very different from a static array. And you can also delete elements, and later we will show you can delete elements from a vector. Next, we can use array as the initial value of some vector. Here I declare an array, and I use this array as the initial value of my vector. So here I use the array as the initial value of this vector. So the elements in this vector will be 5, 6, 7. And we know that here inside the parentheses we have 2 inputs. And the 2 inputs specify the range we want to copy. So we can the two inputs specify the range we want to copy. The first element is uh, the beginning pointer, and this pointer points to the first element, and this pointer points to this pointer points to the element next to the last element. It is better to use a figure to see. You can refer to the figure in page 13. The first pointer points to the first element you want to copy. Now suppose I want to copy 5. Suppose I want to copy 5 elements. Then I let the first pointer points to the first element. And the second pointer, the second input is a pointer point to this position. And the difference between the second and the first pointer will be the number of elements I want to copy. So if I want to copy 5 elements, then the difference between the second and the first pointer is 5. And if I want to copy 3 elements, then the difference between the second and the first pointer is 3. So here, if I want to copy the last 3 elements, then the first input should be array plus 2. If I want to copy the last 3 elements, and the second input should be 2 plus 3, so should be plus 5. If I want to copy the last 3 elements of this array. So we see that if we perform this statement, then the elements in this vector is 7, 8, 9, which is the last 3 elements. So you can specify the range you want to copy. This is method 3. Next, we can copy. We can use a vector as the initial value of another vector. Now suppose I already declare a vector, my vector, and I want to copy this vector to another vector. And we can use the same style. You need to specify the range you want to copy. So you need uh, a variable like a pointer. So you but for vector we don't have pointer. We do not have pointer. So for a vector you need to call a member function. This member function will return an iterator, and the iterator is actually like a pointer. So you can use the begin member function to return an iterator. Then you need to specify how many. You need to specify the second element. The second element is the difference between the second element and the first element is the number of elements you want to copy. So now suppose I want to copy the first 3 elements. So here I use +3. Because if I use +3, then the difference between the second and the first one will be 3. So I can copy the first 3 elements. If you want to copy the whole vector, you can use end. You can use the end member function if you want to copy the whole vector. You can also use begin plus size. You can also use this one, begin plus size. You obtain the whole array. But use end is more convenient. And you can also assign the last 4 element. If you want to copy the last 4 element, you can use begin -1, begin +1, and up to end. In this way, you can copy the last 4 elements. And next, I will introduce method 5. This method is to let you initialize an array like this. For example, I want the initial value of this vector to be all ones. Then you can use this this style. So now suppose I want to declare a vector of 5 elements, and the value of each element is 1. Then I can use this statement. You can change the initial value to 10. You can change the vector size. So it is very convenient to change the vector size or the initial value of each element. You cannot do this for a static array, because for a static array, you need to manually write down the initial value. So for static array, you do not have a convenient syntax like this. Next is a comparison between static array and the vector. For static array, if we want to declare an array with 5 elements, and each element is set to each element is set to 1, then we need to use this statement. While for the vector, we can use this statement. For static array this style has some limitation. For example, if I have 100 elements and you need to type 100 once, which is very difficult. But if you use vector, you only change 5 to 100. So use vector is more convenient. And for this one, if we use static array, its array size is fixed to 5. However, if we use vector, the vector size can be changed. You can always modify this number. The vector size varies with this number. But if you change this number, this number only can be only can be set to 5. Because if this number is larger than 5, then the index is outside outside the legal range. However, for this number is arbitrary. We can push back arbitrary number of elements inside this vector. Because this vector can grow or shrink. However, for static array, we cannot do this. I think the class is over, and we can now dismiss.